This and all talks at the 2020 JavaScript for WordPress conference are brought to you in part by our sponsors Frontity and GoDaddy Pro. Frontity is the easiest way to create performant websites using WordPress and React. It connects both seamlessly so you can focus on building your site instead of all the tooling and configuration. Open source and free to use. GoDaddy Pro Hosting offers a robust suite of free tools to web developers and designers to help them save time managing all their clients and sites. Your free membership also includes advanced 24/7 technical support.
I am just going to jump right in. So I'm just going to share. Here we go. So my name is Joni Halabi. I am a web developer with Georgetown University. And today I'll be talking about kind of my on-again, off-again passion project, which is data visualization in WordPress and Gutenberg. So I just wanted to go through a little bit of expectation setting. So this is a pretty technical talk. It's for developers. I'm going to be talking about Gutenberg block creation, specifically dynamic Gutenberg block creation. So for anyone who creates custom Gutenberg blocks, you can create Gutenberg blocks in one of two ways. One is more of a static way where all of your safe functionality is saved within the JavaScript in the block itself, and it's saved, all of the content is saved in the database. Dynamic Gutenberg block creation is actually when the block is created on the fly with PHP, and it's the data is saved in the database, but the actual content of the block is not. It's generated by that PHP. So we're going to be talking more about that dynamic block creation. And just a warning for some people who are not math lovers, there will be some math. I promise it won't be bad, but there is some math in this presentation. So let's get started. So let's just make up a scenario, and let's say that you're working in a university, and Sam from the admissions office comes up to you and says, you know what, I want to show a chart of how many students are going to come from each class back to campus this fall. So how many freshmen, sophomores, juniors, seniors. And Sam gives us a giant spreadsheet of all of this data. And they say, hey, can you go ahead and create this chart on our WordPress site? So we have a lot of data here that we need to sort of filter through. So our mission here is to create a custom Gutenberg block that will take the data from this spreadsheet that Sam has given us and display it on our website. So great. There are basically three steps to accomplishing this. So step one is we have to import the data into WordPress. Step two is we have to process all that data to make sure that it's in some sort of usable form so we can create our chart. And then step three is to make the chart, and I'm adding an additional fun goal of making this chart both accessible and responsive. So let's get started. So step one, let's import the data into WordPress. So we have a couple of options here. We can say to our content editor, we can go back to Sam and say, you know what, that's great that you have this giant spreadsheet, but I want you to enter all of the data from this spreadsheet into WordPress. And then Sam will probably give us a dirty look because that's a lot of data. Option number two, which is kind of my preferred option, and it's the route that we're going to go in this presentation, is we're going to have WordPress read the spreadsheet for us. Which is what I call the lazy option, because I don't want to do all that work. Sam doesn't want to do all that work. I want WordPress to be smart and read this. So what we're going to talk about first is how to integrate Google Sheets and the Google Sheets API into WordPress. This is great because now we're introducing an element of dynamic data, which means if this spreadsheet that's now in Google Sheets changes for whatever reason, our page will update automatically because WordPress is just reading all this data on the fly. The downside is there is another data source to keep up with. So this is one of those times where you might have to just weigh your options if you don't really want your content editors going into Google Sheets to update the data for this one page on your site, but have to go into WordPress to update all the rest of the content. That's kind of a personal decision. I prefer this way, and it's kind of the more interesting technical way for me. So this is the route we're going to go today. So step one is to get an API key from Google. And you need this API key to do any sort of reading or writing, but in this case, we're just reading all of this information from our Google Sheets. And at the end of this presentation, if you want to go and take a look at the slides afterwards, I have step-by-step instructions about how to go into Google to get an API key. And what you want to do is have WordPress store your API key somewhere. I strongly, strongly, strongly recommend do not hard code. Please, please, please do not hard code your API key into your code. That's not a great option. It's just bad for security. The security part of me is cringing at that option. So what I opted to do is I actually created a little plugin that creates an options page in the WordPress admin. And it just has a little field that will store my Google API key as a setting. So once you have your API key, you're kind of all set up in Google's eyes. What you want to do on your block side when you're creating your block is to have the block store the URL of your Google Sheets. So this is the one and only step that your content editor will need to do. And in your code, your edit function should render, I used a text control. Basically, you're going to have your edit function render a text control that's going to ask the content editor for the URL of your sheet. So this is just a regular React component. I'm taking in a value of my sheet URL, and I have an onChange function that will call a function to store that URL. So sheet URL is an attribute of my block. I can have other attributes if I want to have an attribute for, let's say if I want to have a block title, or I'm actually going to add a couple of other attributes to allow my content editor to tell me which column of my spreadsheet I want to graph. But with sheet URL is just one attribute of this block, and the onChange URL callback is it's a callback from that onChange attribute, and it stores my attribute data. So basically, all it is a constant that's storing this function that's going to grab whatever value the content editor types in, and it's going to set that value as the sheet URL attribute. So step 3 in this process of getting all of my data is to extract the data from this Google Sheet. So we're actually going to use PHP to extract and process the data because we're working with a dynamic block. So when you're working with a dynamic block, a lot of the heavy lifting is done on the PHP side as opposed to the JavaScript side. And this function is called by my render callback from the block. So the first step is to actually get the ID from the Google Sheet URL. And Google Sheet URLs are very, very good at, it's actually very easy to extract the ID. So the ID is literally just the end of my URL. It's embedded in this URL as a series of digits. So what I'm doing is I am just grabbing I'm using a regular expression to grab the URL and just replace anything that is part of the URL that has absolutely nothing to do with my with the sheet ID, with just nothing. So all I'm left with is the sheet ID. And then what I want to do is calculate the range of data to get. So if you remember my spreadsheet, the spreadsheet was divided up into columns. So we had a column of people's names, a column of people's class years, a column of people's majors. So what I want to do is calculate the range of data to get, and I really just want to get the entire column minus the column header. So what this is doing is calculating my range, and it's saying, grab another attribute from my block, which is whatever column I want to create my chart from, and say, okay, I want to grab this column. I want to start with the second row of this column because my first column is just a header. I don't need the header. This %3a is just the escaped value for a colon. And then I want to go to 1,000 rows. You can change this to 2,000, 5,000, whatever very large number you want. You could probably change it to 1,000,000. That might slow things down. I haven't tried with very, very large numbers. But basically what you're saying is I want to get the entirety of this chosen column minus the first row. And then we're going to use the WordPress HTTP class to call the Google API and get all of our data. So I'm setting up my URL for this HTTP call to call the Google API, and the Google API just starts with this this URL right here. I follow that up with the ID of my sheet. And then I'm going to say, I want to get values from the range that I calculated in the last slide. And then finally, I want to append my API key to this call. And that key is what will let me into the Google API, and Google API will actually give me all of this data. So then I'm going to get my data and just return all of this data, and it's going to come back to me as a giant object of data from that column. So the next thing that we need to do is we need to process all this data. So the first step in that is to convert all of this data from this big PHP object into something that we can actually read and process. So we want to decode this into JSON. So I'm going to take my data body, I'm going to decode it, and I'm going to get something like, and I'm going to get something like this. I'm going to get a big array. Sorry, I received JSON, and what I want to do is decode it into an array that I can use in my PHP. I totally just said that backwards. I am so sorry. So what I'm doing, and this array actually gives me a lot of good information. So it's giving me, okay, I have my class range from my class data. I'm grabbing everything from column C. I'm grabbing all of the rows from column C. And then these are all of my values. So I can see, okay, I think I had a copy paste error in here, but yeah, so some of one of my students is a senior, one of my students is a freshman, and so on and so on and so on. I just have this giant, basically an array of arrays, which is a little messy. So we're going to have to do a little bit more processing here. So let's remember the problem at this point. We need to count the number of students from each major. So right now we have this array of arrays, and each array is just giving me information about one student. Sorry, from each class year. So here's my spreadsheet. So what I want to be able to do is actually count the number of students that are in each class year. So I want to count the number of seniors, count the number of freshmen, count the number of sophomores. So what I'm going to do is I'm going to loop through my data, and I'm going to say, you know what? I'm going to grab each of the values, and I'm going to store all of these counts in a new array that I'm just going to call data, for lack of a better variable name. So what I'm going to say is, if I've already found a student who is one of these class years, freshman, sophomore, junior, senior, I am going to add to that number of whatever class year that is. So if in my current iteration of this loop, I have found a freshman, I'm going to say, okay, data, do you already know about freshmen? Oh, good, you do. I'm going to add 1 to the number of freshmen. So if I had 1 freshman already, I'm going to say, okay, we have 1 more. Now we have 2 freshmen. Otherwise, I'm going to create a new item in this array and say, okay, well, hey, data array, you didn't know about freshmen. You do now, and now there is 1 freshman. So at the end of it, I will get an array of, in this case, 4 items, freshman, sophomore, junior, senior, and each of those items will have a count of the number of students that are in those class years. So it kind of looks something like this, which is great. I can use this to start creating my chart. So next step, we're actually going to create the graph. And this is the fun, juicy part that is going to involve some math. So there are a lot of different ways that you can create a graph of this data. You can use a line chart. You can use a pie chart. Pie chart might be more fun, but we're just going to keep this particular example really, really simple. And we're going to create a horizontal bar chart. So each class here is going to get a bar. And we want it to kind of look like this. So from our data, we had 8 seniors, sophomores, and juniors. We had 12 freshmen. So we can see the freshman classes clearly has the most people who have come back to school. So now let's figure out how to make this chart using code. Now, like I said at the beginning of this talk, what I want to do is also make this chart accessible, and I want to make it responsive. So what do I choose? I can either home grow my own SVGs, or I can use d3.js. And you're probably thinking, well, this is a JavaScript conference. You're probably going to choose d3.js, right? I'm actually not. I started at the beginning of my experimentation. I started playing around with D3, and I found it a little cumbersome. I think it's gotten better because I honestly started this project several years ago. But there was an appeal of learning how to code my own SVGs and also figure out a way to make them responsive and make them accessible and just really dive deep into that SVG code. So that's actually the route I went ultimately when I was playing around with data visualization, and it's the route we're going to take today. So you're going to learn about home growing your own SVGs, which is actually really exciting. Some people think it's a little bit intimidating. I actually think it's really cool. It's basically just code. So step 1 of this is we're gonna set up our SVG. So SVGs just start with this SVG element. You're gonna declare your SVG. You're gonna declare a width. You're gonna declare a height. We're actually gonna get to height in a little bit because height for a horizontal bar graph is a little bit tricky. And inside your SVG, you can also, and these are optional, but you can also give your SVGs a title and a description. Now, these titles and these descriptions are things that a sighted user will actually really never see. Sometimes the description will show up as a tooltip over the SVG, depending on what browser you're using, and honestly, whether or not the user knows to hover over an SVG to see the description. But these are really, really great tools because a lot of screen readers will go through an SVG and they will read off the title and they'll read off a description. So you can put all sorts of information in here. I like giving my SVG a title just so somebody who's tabbing through a page with an SVG will, especially using a screen reader, they'll get to the SVG and it'll read off the title. Description, I personally don't really favor, just because sometimes you can put a lot of really great information about a chart in the description. And the description can say something like, this is a chart of all of the students who are coming back to campus sorted by class year. But I also find that information very valuable for sighted users. So my preference is to just sort of nix the description and add it as a caption, either above or below the SVG, so that everybody, regardless if you're using a screen reader or any other assistive technology, anybody can use that. So anyway, after you get past your title and your description, all of your shapes of your SVG go here. And an SVG can contain all sorts of shapes: rectangles, lines, dots, text, circles, freeform, anything that you want. But we'll get to that in a minute. First, we have to deal with our SVG height. So our SVG, you have to declare a height, otherwise you won't actually be able to see the SVG image. So what we want to do is we want to calculate the height by taking the size of our data array. So basically, how many pieces of data do we have? In this case, 4. But we want to take the size of that array, and we want to multiply it by how tall we want each individual bar to be and how much space we want inside, in between each of these bars. So let's say we want each bar to be 16 pixels, and we want the space in between each bar to be 4 pixels. So we'll take the sum of that, 20 pixels, multiply it by the number of elements in our data, 4, and our SVG height is now 80 pixels. So we come up with an SVG declaration of SVG, our XML namespace, our width, our height, and the height will be whatever that calculated variable is. So whatever we calculated from this slide over here. So great. So next is to create our X and Y axes. So that's the line that defines our Y-axis, the line that defines our X-axis, and then the two, I'm only putting 2 scale values at the bottom along our X-axis. So our X-axis and our Y-axis are literally just lines. Like if you were to draw them on a piece of paper, you would draw one line, you would draw another line. So these lines have are just going to use the SVG line element. We're going to give them a role of presentation. And this role is very important because it will tell a screen reader or another user agent that cares about roles that this particular shape in the SVG is really just for presentation. It's just for show. And it's not actually producing or giving any sort of information. Like it has nothing to do with the data. It's just not nothing to do with the data, but it's not actually giving you any of the data. It's just to make your graph more readable for sighted users. So we're going to give this line a presentation, and we're going to say the line is going to start from a certain offset percentage. And it's going to, along my x-axis, it's going to stay on that. And this offset is basically a percentage to give us a little bit more room to add some space for labeling. You can set it to whatever number you want, but it really should be like a percentage. I like using percentages for a lot of these these lines and where the lines start and stop, because it just makes it more responsive. The more percentages I can use for things that just need to be shifted over a little bit, the better it is. So that way, if I say like, all right, I want my offset to be 20%, the SVG can shrink and grow by that percentage, depending on how my screen is. And I actually think this might be my y-axis. I have mislabeled this too. I am so sorry. So anyway, so this axis is going to start at 0, at 0. So it's going to start at the top and it's going to go all the way down to create a line that is whatever the height in pixels is of my actual graph. And then I'm just going to specify my stroke. So basically, if you think about this in terms of drawing with a pen, stroke is what color pen are you using, and stroke width is what size pen are you using. So stroke, I'm using a black pen here. Stroke width, I am using a 2-pixel wide pen. This is where the metaphor breaks down a little bit. And then my other axis, I'm also going to create a line. I'm going to say that this starts with whatever my offset is, so whatever that percentage is that I want to sort of just shift over a little bit. And I want to go all the way to 100%, so all the way to the right side of my SVG canvas. And I want this line to be all the way at the bottom of my SVG. So I want to say, this is actually, apologies, this is actually my x-axis. I want to say that this line is going to be at the very, very bottom. So it is going to be at whatever the height is of my SVG in pixels. So that 80 pixels that we determined many slides ago. And again, I have my pen strokes here. So I'm using a black pen. I'm using a 2-pixel wide pen. And then I'm doing my scale. So my scale is that 0 on the left side and the 12 on the right side along that x-axis. So I'm going to use the text SVG element. Again, I'm going to give this a role of presentation because this isn't, it's giving me information, but I'm actually going to give a lot of the data. A lot of the data is actually going to be presented in the bars itself. So I don't want to necessarily confuse anybody with a screen reader, for example, just randomly belting out 0 or 12. So I'm going to give this a role of presentation just so my screen readers don't confuse anybody and just read off a random 0. So this is going to be set at my offset percentage again. And the Y value of this particular text, so how far down it is in my screen reader, is going to be whatever my height is in pixels of my graph, plus a little bit more, because I actually want it to be, I actually want the 0 to sit below the line that I created for my x-axis. And then the fill is, it's basically equivalent to the color property in CSS. So I want this, I want the 0 to show up in black, and I want my font size to show up as 14 pixels. Unfortunately, like putting rem or ems in here didn't really work. It just, SVGs just don't like that. You have to enter things in pixels. So this is where responsiveness breaks down a little bit. I'm not a huge fan of it, but I just put in 14 as something just a little bit under 1M. And I'm going to do the same thing with my scale number on the other side, on the right side of my x-axis. So again, I'm going to have this text element. I'm going to give it a role of presentation. I want to put it along the x-axis, like almost at the ends, but not quite. I chose 96% because it seems like a really good, it just visually seems like a good place. If you actually set this to 100%, this text element will get cut off by the edge of the SVG. So if the max value, the value of this was 12, you might see like a sliver of the 1, and you won't actually see the rest of the 1 or the 2. And I put max value. This is not a real value. You would want to substitute this for some sort of actual number. What you would want to do is calculate the max value of whatever is in that data array. So if you remember our data array had 4 elements. So what you would want to do is go through your array and say, okay, which of these elements has the largest number, and you want to plop that number right in here. So all of this code that we've gone through so far, our 2 lines for the axes and our 2 text element for the scale, all of those you want to put inside what SVG calls a group. So this is, if you want to think about it in HTML terms, it's sort of like a div. It's basically just a nice little group that you can put more code into. So user agents, like screen readers, like your browser, user agents will know that all of that code belongs together. So the group element in SVG is literally just the G tag. G stands for group. They abbreviated it. And you can put classes on these groups. You can put ARIA labels on these groups. I'm not putting an ARIA label on this particular group because it's, again, like I said before, it's not actually giving data. It's not actually giving any data. This is basically just all of the stuff that is around our data. But if you wanna have an ARIA label that says ARIA label, this is the setup for my chart, that ARIA label will actually get read by user agents like a screen reader. So if we put all of this together, our lines and our text elements all go inside this group. And now our browser knows, okay, all of these belong together as part of the setup of the chart. And you can use this class if you want to give some more styles to the chart itself. You can use this class to target it with your CSS, or if you want to, I don't even know what you would do with JavaScript in an SVG. Like you could target it with basically anything. It's just like a regular any other HTML element. So step 3, we have finally come to the fun part, creating our bars of data. I know it's been a half hour of me talking just to get to creating the bars, but this is the truly, truly fun part. So we get to show our data. So we're going to go back and we're going to start a second group, and this group is going to contain all of our bars. So all of our bars in a horizontal bar graph. If you think about it, it's kind of just like a list of data. So I'm giving this particular group a role of list. And what that does is a screen reader will go in and it will say, oh, this is a list. And it will declare to the user of the screen reader, you're about to read a list. And if you put an ARIA label on it, you probably want to choose a better ARIA label than bar graph, but you can put whatever label you want in here, and a screen reader will go in and it will say, usually something like list, bar graph of students sorted by classes, or whatever you have in your ARIA label. And then all of your elements for your bars will go inside of this group. And the screen reader will read off each of these bar elements as though they are elements of a list, like an unordered list or an ordered list. And the nice thing about this is a lot of screen readers will also count the number of lists. So it will, VoiceOver in particular, it'll actually say like list of 4 items. And then it will go on and read the ARIA label. And then a user can click in or navigate inside of the group and navigate from one bar to another bar and get more specific information about each bar, which is super neat to listen to. So to create all of the bars in your graph, what you basically want to do is take that data array that we created, I don't know, 20 slides ago at this point, and we want to loop through that array, and we're actually going to create a group for each bar, so we're going to have a group inside of a group, and each group is going to contain the bar itself, a text label for that bar, and optionally we can put in a description to give a user some more information about that bar. So let's get into it so we can actually see what this looks like in code. So inside of that first group that we created, that was the list, we're going to create a subgroup with a role of list item. So if you're thinking about this in terms of HTML, our parent group that had the role of list is kind of like your UL. And this subgroup with the role of list item is just like your LI. So for each of these groups, we're going to designate it as a list item. These groups can have their own ARIA label, and this is a great place to put in information about what the label of this group is and what the data is. So the label would be freshman 8. I actually forget the real numbers. I think it's freshman 12 or senior 8. And you can put whatever you want in here, but I find it very, very, very valuable to put in the exact information about what that particular bar is showing. And then tab index 0 is basically saying, I want this group to be tabbable. So this is great for keyboard users. So tab index 0 will just will put this group into the natural tab order wherever it lies in the DOM. So somebody tabbing through the site can actually tab through all of the links and tab through all of the other tabbable elements on your page, and it will treat this group inside of your SVG just like any other tabbable element. And then you can optionally add this description. In most cases, if you have a very, very simple bar graph, the ARIA label is probably enough. For our example, the ARIA label is, I'm sure, enough. But if you have some more complicated data that requires some context, for example, the description is a good place for that. And the description will also be read by a bunch of screen readers. I say a bunch and not all because screen readers are not, this is a little aside, screen readers are not actually standardized like most web browsers are. I know, anybody, you're probably laughing at me. I can't actually see the chat, by the way. So if you are laughing at me at this point, that's cool. But yeah, like web browsers, at least at this point, you can expect them to behave in the same way in most cases. With screen readers, JAWS acts very differently from NVDA, which acts very differently from VoiceOver on a Mac, and there just isn't a standard. So that's why I use a lot of language around screen readers, like most or some, or this tends to happen. But yeah, so if you have a graph where each of your bars really needs a little bit more description, you can put this description in here and it will generally be read by your screen readers. It will also, for sighted users, if you mouse over a bar with a description, it will show this description as a tooltip. So enough about description. So within this group, you will also have your bar element and your label element. So the bar element, in this case, we're going to use a rectangle because our bars are basically visually rectangles. So because the group and the description in the group carries all of the information, all of the data information for a screen reader about this particular bar, I'm actually giving this rectangle, again, a role of presentation. So it doesn't get read again by a screen reader. You can choose to do different things, but I usually err on the side of let's give screen reader users the information that they need, but let's also not annoy them. But every case is different, and your chart might be might necessitate the bar to actually be read for whatever reason. So anyway, enough about presentation. The X, so with a rectangle, basically what you're saying is I want to, you want to declare the X and Y values, so the point value of where your rectangle starts. And this goes from So these numbers are generated from the top left. So the top left is x0, y0, and your bottom right is your maximum x value and your maximum y value. So the offset is going to be that same percentage offset that we used earlier for our axes, and that will also help with our responsiveness. So the x value will kind of shift over to the left or shift over to the right, depending on how wide or narrow our screen is. And then our y value is actually going to be calculated based on where we are in our loop. So our loop needs to take into account how many bars have been generated so far. So are we on our first bar? Are we on our fourth bar? And then it wants to take that number and multiply it by the height of each individual bar plus the gap. So I think earlier I mentioned, like, let's say, for example, we want our bar height to be 16 pixels, the gap between bars to be 4 pixels. So we want to multiply whichever bar we're on by 20. So if we're on our first bar, the number of bars so far that have been generated is actually 0. So 0 times 20 is 0. So it's actually going to start at the very, very top. And then our next bar will be 1 times 20, and then 2 times 20, and then 3 times 20. So these bars will be displayed further and further down our SVG. The width will be whatever you want. You can choose whatever percentage. Actually, the width is going to be calculated based on the data of that particular bar as a percentage. And we'll get to that in a second. The height is going to be whatever you want. So the height can be, it really should probably match this. I just put in 30 as an example, but it should really match this bar height variable number over here. So your height will really be bar height. And then the fill is basically whatever color you want this bar to be. So I chose 00F or blue. So the bar's width. The width of the bar is actually going to be the value of whichever, the value of what the bar is going to be. So let's say we're on our freshman class bar. So that value is going to be however many freshmen are coming back, which is 12. And we're going to calculate this as a percentage of the max value. So, for example, so our data had 12 freshmen and then 8 of everybody else. So our freshman class is going to be 12, since we're on freshmen, divided by our maximum value, which happens to be 12, times 100. So 12 divided by 12 is 1, times 100 is 100. So this particular bar for the freshman class is going to be 100%. For every other bar, the value was 8. 8 divided by 12 is, oh God, don't make me do math on the fly. Point like 666666666 times 100 is whatever, 66 2/3 percentage. And then our bar label, and this was the label all the way to the left of our SVG. Our label is going to be another text element with a role of presentation. This time the X value, so how far left it is actually going to be 0, because I want it to start at the very, very left-hand side of our SVG. And the Y value is going to match the Y value of our bar. So it's going to be that same calculation of the number of bars that we've drawn so far times the sum of the bar height plus the bar gap. The fill, just like our other text elements, this is basically the pen ink that we're using. So my fill is black. My font size is 16. And then we're going to use whatever label that exists in our data. So in this case, our data, this is actually the key for each data array element item. So all together, we have our outer group, which has the role of list. And then we have a whole bunch of child groups that have that role of list item with our ARIA label, our tab index. We have our optional description. We have our rectangle that is our bar. We have our text element that is our label. And we get this beautiful looking graph. You can make it much prettier if you want. There are definitely ways of making SVGs prettier. I have a couple of resources at the end of this slide deck. But that is our graph. Thank you so much. These slides are available live literally right now, although I might make a couple of corrections. I apologize for those typos earlier in the slide deck. But yeah, you can go to talks.thatdevgirl.com/dataviz to see the slides if you'd like to review them again. And these are my links. And thank you so much. I have, I think, 4 minutes left. So yeah, if anybody has any questions, feel free. I love questions.
First of all, thank you so much for this awesome presentation. I can only speak for myself, but I learned a lot about SVGs that I didn't know before. So I'm super grateful. I know there's one question using the Q&A feature, and I think you mentioned this in the very beginning of your talk, but how do you select a specific sheet on the spreadsheet if there are multiple sheets?
Oh, that's a good question. I'd have to dive into the API. There is a way where you can put that into the URL for the API. I forget the specifics. But yeah, there is a way you can do that with the Google API. It's kind of like when you're creating a formula in Google Sheets, and you can reference a value from one sheet inside of another sheet. I think it's like bang and then the sheet name. But I'm trying to remember that off the top of my head. To be honest, I'd have to Google that, but that is definitely possible.
Cool. Yeah, if there are any other questions, put them in the chat now. We have about 3 minutes. If there are questions, you can post them here, or otherwise, like you mentioned, people are probably free to reach out to you in Twitter or over the website.
Yeah, I know that was a very fast overview. There are a lot of other details that I did not go over, mostly for time. I could probably talk about this for about 3 hours. I am so sorry. But yeah, definitely reach out if you have other questions. Like even after the fact, if you at me, I at back. So how did I start this as a passion project? So at work, we actually, once a quarter or once a semester, we actually do something that we call Serendipity Day, which is something that I understand was started, or at least heavily adopted, at NPR. And one of my teammates brought it over to us. And basically, it's just a day of working on a project that you want, like whatever project you want that's been sort of stewing in the back of our heads. It's not necessarily work related. And it started, this particular project started because I really, really wanted to learn D3, ironically enough. So the first iteration of this, I was working with Gutenberg in very, very, very early times before it was actually released as part of WordPress 5. And I was working with this, and I was working with D3, and I was getting very frustrated with D3. Like I'm the kind of person that wants like super duper control over everything, and D3 was just doing too much behind the scenes, and I did not like that, which is actually how I ended up just saying, you know what, if D3 is gonna annoy me and just write SVGs in the end, I'm gonna write these myself. But yeah.